Okay, let's give you guys some more practice. So establish if this integral will converge or if it will diverge. So press pause and have a go. Okay, so to do this, realize that this thing here is trapped in between 0 and 1. Because if you look at the normal sine of x graph, if you look at the normal sine of x, it's trapped between 1 and -1. So when you come to square it, then this whole thing here will be greater than 0, and it will be less than 1. So the highest value that this thing here could be is the number 1. So if you look at this, so to do this, realize that the highest value that this thing here could be is the number 1. So if you compare this to this, then if the highest value that this can be is the number 1, then this whole thing here must be less than or equal to this thing here, because the highest value that this thing could be is the number 1. So this must be the highest possible scenario. So this thing here is greater or equal to this thing here. So now if you remove this tiny bit here, here you've got, well, this thing here is very similar to this thing here. But then if you remove the 1, if you remove the 1, then you're going to make the denominator smaller, meaning that this thing here will be greater or equal to this thing here. So really we should compare this with this thing here. Okay, so let's just rewrite this. Let's just rewrite this as this: x to the power 3 to the power of a half. So this times this, that will then give you this. So now we know that this thing here will be less than or equal to this thing here, and you should by now you should ingrain this in your mind. If you have 1 over x to the power of 1, which would be this thing here, from 1 to infinity, we've already established many times that this area here will diverge. But if you increase, so when it's to the power of 1, this area here will diverge. But then if you increase this slightly, if you make it slightly bigger than 1, then your graph will look something like this. And then this area here will then converge. The point here is that this thing here is above 1, so therefore the area will converge. Now if this thing here, if the area here converges, then this being greater or equal to this thing here, this thing will have no choice but to also converge. So the point here is that when you get to this stage here, you should realize that the area from 1 to infinity of 1 over x to the power 3 over 2, this area here will converge. Well, this being smaller, so I don't know what it looks like, but this thing here is smaller. This thing here being smaller than this will have no choice but also to converge. So therefore, because this converge, this therefore must also converge. Okay.